Now, in the last lecture, we talked about how we were going to survey these east-west lines, these baselines. Now, you got to remember that because meridians converge, these east-west lines turn out to be curved lines. They're called rhumb lines. And we talked about that in the last lecture. Now, there's three different methods of doing it. And the first one we're going to talk about is the solar method. And in order to do the solar method, an observation is made on the sun to determine the direction of astronomic north. You take a sunshot. A right angle is turned and the line is run for 40 chains. Remember, 40 chains being half a mile. A monument is placed and the process is repeated. Now we're going to go through a couple of these slides and then I'm going to have a graphic and I'll show you what I'm talking about. Because meridians converge, each time a right angle is turned, there will be a slight change in the direction every half mile, every 40 chains. The series of lines that we do like this, that we lay out like this, will closely approach the parallel of latitude. That's what we're after to do. Okay, here we have a graphic of what I was talking about. If you take a look on the left side of this, we have a line going north. That's the astronomic north that we take a sunshot. They used to use sunshots to determine where true north was. And then they turn an angle of 90 degrees and they go out 40 chains, set a monument. Then they move on to that monument they just set. They sight north again, true north, turn 90 degrees, go 40 chains. And as you can see, as they go across from west to east in this case, they keep turning 40 chains and turning 90 degrees and going out 40 chains. And what they have there is an approximation of a parallel of latitude. And that's what we're trying to accomplish. The next way of doing this is the tangent method. Now, the tangent method for determination of a true latitude consists of establishing a true meridian at the beginning point, turning an angle of 90 degrees, and running this out to the east or to the west as required. What that's going to do for us is that's going to set up this tangent that we're going to use to determine where the latitude is. Now that tangent line is projected for 6 miles in a straight line. And as the measurements are completed for each corner, that is, along the tangent line, they're going to set temporary monuments every 40 chains for 6 miles, 480 chains. The proper offsets are going to be then measured north from the tangent line to the parallel of latitude, and the corners are established. And we're going to see how that works. Now, at the point of beginning, when you turn the angle, the tangent line runs true east or west. But as you go down the 6 miles, the bearing of that tangent is going to be going to the southeast or the southwest, depending on which way you're going. Reason for that, again, is the convergence of meridians. Now here's a graphic showing what this tangent line is like. We're going to start on the west line where you see the 0 distance. Then we're going to establish true north. Then we're going to turn an angle of 90 degrees. And we're going to go out 40 chains, then 80 chains, then 120, 160, so forth and so on, all the way down for 6 miles, which is 480 chains. Now that straight line is the tangent line. Those numbers on the top there, 31, 32, 33, 34, 35, and 36, are just the sections that we're going to put these numbers on. So what we do at 40 chains, the offset is so small, we usually do very little, if anything at all, on that. But at 80 chains, we're going to offset to the north a given angle and distance. Now, these angles and distances were given to the surveyors in a book of tables called the Standard Tables. And we'll be seeing more about that as we go on. But let's take a look at what one of these tables might look like and how we can determine what angle to turn and what distance to go off the tangent line. Now, what you're looking at here is a table out of those standard tables that I was talking about for a parallel of latitude of 45 degrees, 34 minutes, 30 seconds. I'm going to show you what the actual tables look like, but what the surveyor had to do is he had to interpolate between the different degrees on the standard tables to determine what he needed for his area. Now you'll notice in the left-hand column it says chains on the tangent. And it's 0, and then the offset in lengths because they used the Gunther's chain for everything. Obviously 0, and the azimuth of the tangent is east. But take a look at 40 chains. The links are less than 1 link, and so it was so close they probably didn't do anything or very little. But take a look at 80 chains. And at this parallel of latitude, the offset in distance was 1 link, only 66/100ths of a foot. But take a look at the azimuth of the tangent, or the bearing of the tangent, if you will. That tangent is now heading south 89 degrees, 59.1 minutes east. And so if you knew the direction of the tangent, you could turn the angle back to true north. And you go up 1 link and you set the monument. And you keep that up all the way through that 6 miles. Now take a look at the very bottom. The chains on the tangent is 480 chains. That's 6 miles away from where you started. The offset in links is 37 links that you're offsetting. And the bearing, or the azimuth of that tangent at that time, the bearing, is south 89 degrees, 54.7 minutes east. We knew that. We can turn to true north, go 37 links, and put our monument, and we're on that true parallel of latitude. Now, like I said in the last slide, offsets from the tangent can be found in tables 12 and 13 of standard field tables. Again, these tables were produced by the government and given to the surveyors so they could do their job. Let's have a look at tables 12 and 13. What you're looking at here is tables 12 and 13 of these standard field tables. You can get these online, by the way. On the left-hand page, it's the azimuth of the tangent to the parallel. Now you'll notice that along the left column, it says lat. And that's the latitude that you're on, from 25 degrees to 70 degrees. And then you have the azimuth of the tangent, or the bearing of the tangent, from 1 mile, 2 miles, all the way to 6 miles, and it'll change as you go on. Now you'll notice that this table is only to the nearest degree, so if you were working between the 2 degrees, you'd have to interpolate to determine what you needed for the type of work that you're doing. Now table 13 on the right is the offset in lengths, and it's the same sort of thing. But you'll notice that it's half mile, 1 mile, 1.5 miles, so forth and so on, all the way to 6 miles. And it gives you the offsets that you're going to have to go from the tangent line to the parallel of latitude. So that's what the field tables look like. The last method we're going to look at is called the secant method. And this is by far the best way to do this, I believe. A designated secant is a great circle which cuts the parallel of latitude at the 1st and the 5th mile corners, and is tangent to an imaginary latitude curve at the 3rd mile point. Now we're going to go through and we're going to explain these in the next several slides, but I also have a graphic that when you see it, I hope all this stuff will come together for you, because it's not rocket science. It's just another way of doing, laying out a latitudinal line. Now in the secant method, from the point of beginning, the secant line has a northeasterly or northwesterly bearing. You're starting south of the latitude that you're trying to survey in. At the third mile, the secant bears east or west. And from the third mile to the 6th mile corners, the secant bears southeasterly or southwesterly. So we're starting on the west side. In this case, we would go south of the parallel of latitude at a given offset, turn the secant angle, and go out for 6 miles. Like I mentioned in the last slide, the secant method of determining a true latitude curve consists of establishing a true meridian south of the beginning quarter at a distance taken from tables 14 and 15 of the standard field tables. Okay, we looked at 12 and 13. Those were for the tangent. Now tables 14 and 15 deal with the secant method. Now from this temporary point, a proper horizontal angle is turned, as taken from the tables, to the northeast or the northwest, depending on which way you're going. And that's going to define the secant line. From the temporary point to the 1st mile, and from the 5th mile to the 6th mile, the secant is south of the parallel of latitude. Remember, the tangent was south of the parallel of latitude, and the 1st mile and the last mile of the secant is also south of the parallel of latitude. Now, from the 1st mile to the 5th mile along the secant line is north of the parallel latitude. So your offsets are going to be to the south. So it starts out south of the parallel latitude, and at the 1st mile it starts going north of the parallel latitude, and at the 5th mile it's south of the parallel latitude again. And you'll see when we take a look at the graphic how this all comes together. Now the secant is projected for 6 miles in a straight line, as we talked about. And as the measurements are completed for each corner point, proper offsets are measured. Now, what they're doing along the secant line, just like with the tangent line, they're just dropping off temporary points every 40 chains. Then from those temporary points, they're offsetting to the secant line, whether it's measuring to the north or to the south from the secant line. And then they set the proper corners. So that's how they're going to start doing things. And our next slide, we're going to see a graphic, and you can see graphically why the secant line, in my estimation anyhow, is so much better. Now what you're looking at here is a parallel of latitude laid out by a secant line. Now over in the west, or the left side here, you'll notice that we have a true north line, and then we have a dashed line going to the south where we have our 0 distance. That's the point of beginning of the secant line. We have an offset to the south from the parallel of latitude. We occupy that point, we determine true north, and we turn the angle for the secant line, and it's going to be less than 90 degrees. Then we go out 40 chains, and you'll notice that we're now offsetting north to the secant line. But at 80 chains, it's where the secant line parallels or crosses the parallel of latitude. And then from 80 chains to 120, 160, 200, 240, 280, 320, 360, and 400, the secant line is north of the parallel of latitude, and the offsets are to the south. At 400 is where the secant and the parallel of latitude intersect. And from 400 to 480, that's the last mile, the offsets are back to the north. Now you'll notice at 3 miles, 240 chains, the secant is the largest there, and the parallel of latitude at that point is east-west. So it's just straight south drop at that point. And we're going to look at some tables so you can see what I'm talking about here. Just like we saw in the tangent method, this is a parallel of latitude for the same parallel, 45, 34, 30 north, but this is for the secant. Now, chains are the left-hand column along the secant line. The center is the offsets. Remember, depending on where we are, we're offsetting to the south or we're offsetting to the north. And you'll notice that at 0 chains, the offset is 5 lengths. That's because we want to be south of our beginning point to lay out the secant line. And the bearing of the system, the secant, that is the first angle we're going to turn, is north 89 degrees, 57.3 minutes east. At 40 chains, the offset is only 2. But now take a look at 80 chains. There's no offset, but we do have a bearing of the secant line. We're going to go down to 240 chains, which is the 3 mile mark, and take a look at the offset. It's 4. That's the largest offset it can be, 4 lengths. And the secant line is east-west at that point. And then from 240 chains to 480 chains, you'll notice that the secant line's bearing is in the southeast. And the offsets are a mirror image of what they are before the 3 mile. So one's a mirror image of the other. The reason I think that the secant is better than the others is because these offsets are so much less, and it's less chance to make a blunder. So let's take a look at these tables 14 and 15. As you can see, table 14 is the azimuth of the secant, and table 15 is the offset in lengths from the secant to the parallel of latitude. You'll also notice that the distances and the angles, the azimuths of the secant, only go out for 3 miles. And the distances only go out for 3 miles. That's because the second 3 miles is the mirror image of the first 3 miles. So if you have the first 3 miles, you have the second 3 miles. And this is where the surveyors would get their information to lay out a parallel of latitude using the secant method. Now, it should be noted that the 2009 manual doesn't mention any of these above methods. It simply says to determine the determination of the alignment of the true latitudinal curve is described in the record, and that's in section 3-11 of the 2009 manual. What they mean there is with the equipment we have today and the computer programs that we have today, go ahead and calculate where that line of latitude is, lay it out the way that you would lay out anything, but document it so a surveyor in the future can go back and look at your records and see how you did it to make sure it was done correctly where it's supposed to be. So that's the trick. Document your work. And you can still use the tangent or the secant method. Solar method's not used much anymore. It's considered too crude with the equipment and everything we have today. But you can still use the tangent or the secant if you chose to. That concludes this lecture. We talked about the solar method, we talked about the tangent method, and we talked about the secant method. 3 different ways of doing the same thing. That is laying out an east-west line wherever we have to lay out an east-west line, whether it's for a township, for a baseline, or for other lines that we're going to be talking about very soon. We use this method to do it because east-west lines in the public land survey system are rhumb lines or a curved line. So take a look at your notes, and then let's move on to the next lecture.